Hey guys, hope you're well. So this is going to be one of the most important lessons when it comes to electrical circuits. I'm going to explain all the foundational things that you need to know to really understand this chapter quite well. So we're going to be looking at quite a few things. We're going to be looking at a series circuit, and I'm going to teach you some amazing things about that. We're going to look at parallel circuits, and then we're even going to look at circuits that have series and parallel all combined, and I'm going to show you some interesting things when it comes to how to know what the current and the voltage values will be. Okay, so stick around, there's quite a bit here. So here we have an electrical circuit. Now, the way that electricity moves is it always starts at the long line, the positive one, and it flows out of that. Now remember, the electricity can never go through a voltmeter. It never does that. So it doesn't go that way. It goes this way. Then it goes through this device over here, which is an ammeter, which measures the current. The electricity then carries on, gets over here. Now remember, it cannot go up this way because it never goes through a voltmeter. So it rather goes straight like that. And then it keeps going. And by the way, this is a resistor. And a resistor, like we've seen in previous lessons, is anything like a type of device, like a light bulb, a television, a microwave. It's any type of device. Then it goes through another ammeter over here. Then it goes through another type of resistor, and then it keeps going, goes through another ammeter, and then goes through another ammeter, and then it completes the circuit. So can you see that the electricity only follows one path? There was no area where it decided to go on a different path. For example, later on when we look at parallel, we'll see that the electricity is going to be able to follow different pathways. That did not happen in this one. So that is what a series circuit is. It's when the electricity only follows one path. Okay, now, the way that an electrical circuit works is that the battery supplies voltage. So the battery gives the voltage to the charge. Those charges can then go through the circuit, and they can use that voltage or energy that the battery has given, and it can use it to go through resistor number 1 and resistor number 2. So for example, if this voltage is 8 volts, then what maybe happens is that this voltmeter will be 2 volts, and then this one would have to be 6 volts. Can you see that? Because what happens is that the battery gives 8 volts, and then the charges use the 8 volts in the circuit. So maybe this was a light bulb, so it only uses 2 volts, and maybe this one is a fridge, so it uses more energy, so it uses a 6 volt. Okay, so to calculate this voltage value, well, there is a formula that I want you to look at. The voltage value, or V, is going to be equal to the voltage, or let's say the sum of voltage, or voltages, in series, plus, and then I'm just going to say voltage of parallel branches. Okay, but that part there is going to be, we're going to have to talk quite a lot about that. I will talk to you about that when we get to parallel circuits, okay? But I just want you to write this one down so long, and this formula is going to be really important for us to use. They won't show you this formula in class, but it's something that I've come up with to help make this section a little bit easier. And when I say V, you need to understand, when I say V, I was talking about the battery voltage, but your teacher might not always call it V. Maybe they call it V1, and then they call this one V2, and then they call this one V3. So when I say V, I was talking about the battery, so the voltage of the battery. Okay? That's probably what the formula should rather say. Okay, but stay tuned because we're definitely going to have to talk about this one. There's something interesting that I need to tell you about this one. So can you see that if you wanted to work out the voltage of the battery, you could say the sum means when you plus all the voltages in series. So that's 2 volts plus 6 volts. And that would have given us 8 volts. And that's where we got 8 volts. Okay, so there we have it. I've just written something down. And then this part here means that there's something important that we need to talk about when we look at circuits in parallel. The next thing I want to talk about is the current. So in parallel, in series, which is the type of circuit that we have here, the current stays the same. Current stays constant. So what I mean by that, and you can think about it, we said that electricity starts over here and then it flows this way. So maybe we have a total current of 5 amps. Now over here it's still going to be 5 amps, and then it gets over here and it's just going to remain 5 amps all the way around. The current does not change in series. So that means this would be 5 amps. On this ammeter it would still be 5 amps. Over here it would be 5 amps. And over here it would still be 5 amps. So at the moment, all that I want you to remember is the following. So let's have a look here now. And let's remember the rules that we've learned so far. So what we can say is that the voltage of the battery, which is V in the 6th circuit, is the sum of all of the voltages in series. So this circuit is all in series. It starts here, and then it goes like this, and then it goes through R1, it goes through R2, it goes through R3, and then back to the beginning. So you see that we never changed the path. We didn't go off on a different pathway. The current never had to split, and so this is a series circuit. So we can say that it's the sum of all of the voltages in series. So that's going to be V1 plus V2 plus V3, and then it says plus all the parallel branches, but there aren't any parallel branches, and so we're just going to leave it like that. So that's something important for this circuit. And then in series, current remains constant. That means that the current over there is the same as the current over there, which is the same as the current over there, same as A4, and the same as A5. So all of those would be the same. So the only summary that I want you to remember now for series circuits is that in series, current remains constant. And then that formula that I showed you about the battery, or that you are going to use for all circuits. So it's sum of voltages in series plus parallel branches, which we haven't looked at yet. We haven't looked at that, and there's something special that I need to show you there. Okay, so let's have a look at this circuit. So the circuit always starts here at the positive terminal, and it goes like this, and then it gets here. Now, because it gets here, and by the way, it doesn't go this way because it never goes through a voltmeter. Now, when it gets here, it can go 2 different ways. So some of the current is going to go that way, and some of the current is going to go that way. It then joins together and carries on like that. So because the current had to split over here, we will say that this area is called a parallel, or that's a parallel part of the circuit, okay? Then all of the rest, well, that's still going to be in series. That's still in series, okay? So that part's in series, and then that part is in parallel. Now, I need to teach you guys a few interesting things. Now, here it is. In parallel, the voltage of each pathway is the same. But now we need to talk about that carefully. So let's say, for example, we've got this part of a circuit, okay? And then some of it goes this way. So there we've got a resistor, and then there we've got another resistor, okay? And there we've got that. Now, let's say we've got a voltmeter, V1, and another voltmeter, V2. So what I've just told you is that in parallel, the voltage of each path is the same. So that means that V1 and V2 will be the same. Okay, but now be careful. There's something very interesting we're going to talk about. But first, let me just show you that this is parallel. So the electricity would go over there, and then some of it would go this way, and the rest would go this way. And then it would combine again and go like that. So when it's in parallel, the voltage in the top branch is the same as the voltage in the second branch. But here comes the most important part. If we have a circuit that looks like this, where in this top branch we've got 3 resistors, for example, and in the bottom branch we only have 1 resistor. So let's go call this R1, R2, and R3, and let's call this R4. And let's say we had a voltmeter over here, V1, V2, and V3. And then here we had a voltmeter called V4. But let me just show you that this is parallel. So here you've got this yellow circuit arriving over there. And then once you get over here, well, that's when the current can then split. So some of it would go that way, while the rest would go this way. It would then join up to go that way. So the rule that I showed you says, in parallel, the voltage of each pathway is the same. I didn't say that every single device has the same voltage. It is the total pathway. Okay? Now, would you agree that from here up to here, that is in series? Why? Because that green pathway cannot split. It's only going through there. So that part from there to there, that is called series. Okay? So, to be able to work out the total voltage of this pathway, now the rule that we spoke about, it says, in parallel, the voltage of each pathway is the same. So, let's look at this pathway. To work out the total voltage of that pathway, you are going to plus all of them together. So for that pathway, you are going to plus all of those voltmeters together. Because this part over here is actually series. From here up to here, that is in series. Because the current can only go like that. It can't split. It only goes through R1, R2, and R3. So to work out the total voltage of that pathway, you add them together, V1 plus V2 plus V3. Now, whatever that total adds up to, maybe that adds up to, 12 volts maybe, then that must be the same as the voltage of all the other pathways. Have a look here. In parallel, the voltage of each path is the same. So that means that this pathway would also have to be 12 volts. So let's practice this a little bit. So, for example, if you have something like this, and you've got a resistor, and then you've got another resistor, and then down here we've only got one resistor. Okay, let's actually just do this. Okay, now if this voltmeter here, let's say that V1, let's say that's a 2 volt. Let's say it's measuring 2 volts, and let's say this one is measuring 7 volts. Then you got to try figure out what is this voltage. Okay, so try give that a go. Try think about that. Well, the first thing to understand is that electricity would normally flow over there, and then some of it would go this way, and the rest would go this way. It would all join up again and carry on, and you could imagine the electricity is flowing in that direction. So this is parallel. So what does our rule tell us? In parallel, the voltage of each path is the same. So in this top path, there's 2 voltmeters, so you just have to add them together. So for that path, it would be, so that would be 2 plus 7, which is 9 volts. So that's that pathway. So that means that this pathway would also have to be 9 volts, but this pathway only has 1 voltmeter, so this would also be 9 volts. Let's look at another example. Let's say we have something like this. So once again, this is parallel. The electricity would flow there, and then some of it would go this way, the rest would go this way. Oh, let's say that this is R3 and R4, and then it would carry on like that. So if you look at this branch, this pathway over here, if you just add the voltages together, so the voltage of that path would just be 6 plus 2, which is 8 volts. So that means that this path must also be 8 volts. They've told us that this one is already 3 volts, so that means that V1 would have to be 5 volts. Why? Because then if you look at this pathway, if you look at that pathway, it would be 3 volts and then 5 volts, which would give you 8 volts. And so the voltage across this pathway will now be exactly the same as the voltage across that pathway. Okay? So that's what I want you to know for now in parallel, is that the voltage of each path is the same. So for this circuit, we will say that V1 is the same as V2 because that's a voltage and that's a voltage. Okay? The next thing is that you can see there's this voltmeter number 3 over here, which is measuring all across there to there. So it's measuring the entire parallel part. So that one is also going to be the same as V1 and V2. You're not going to say V1 plus V2. You're actually just going to make it equal to V3 like that. Okay? Then the next thing is that, can you see that A1 and A4 are in series? They're not in parallel, they are in series. They are part of the main circuit. Now we know that in series, current remains constant. So we could say that A1 is the same as A4. Okay? Now let's quickly talk about A2 and A3. Let's see what happens there. So let's imagine that we've got, let's say there are people that are busy walking. So let's say, let's just stick to normal electricity. Let's say the current flowing over here is 5 amps. 5 amps of current. Now when it gets to this part, some of the current is going to go this way and follow the green pathway, and some of the current is going to go this way and follow the blue pathway. Okay? Now let's say, for example, that 2 amps goes this way. Well, then what happens is that 3 amps will go this way. So that when you add these two numbers together, it still adds up to 5. The 2 amps is then going to go all the way through here, and the 3 amps is going to go all the way through here, and then they're going to join together over here again, and then carry on as 5 amps. Okay? So when you are in parallel, those currents do not have to be the same. Okay? But they will add up to the total current in the main circuit. So here's a little activity that I want you to try. So what we have here is we've got 5 amps of current approaching. Now let's just see if this is parallel. So the current gets there, then some of it would go this way, and then the rest would go this way, and then it would carry on again. So let's actually put another little ammeter over here. Let's call this one A3. Okay. So what they've told us is that the current over here is 2 amps, okay? And they've also told us that this is a 4 volt, and they've told us that this is a 1 volt. So the first question says, determine A2. So A2 is over here. So how much current is flowing there? Well, we started off with 5 amps, and how much goes this way? Well, if you look at the ammeter reading, it's 2 amps. So how much is left over? Well, 5 minus 2 is 3. So that means 3 amps goes this way. So any ammeter that you connect over here will be 3 amps. So that would be the answer, 3 amps over there. Okay? We're also going to say determine A3. Right. The next question says determine V3. So V3 is over here. So now we've got to go back to our rule in parallel, which says that in parallel, the voltage of each pathway is the same. So if you look at this top pathway, what is the voltage? Well, there's only one device, and so the voltage of that pathway is 4 volts. That means that this pathway must also be 4 volts. This whole path has to be the same as this whole pathway. So the blue pathway must also be 4 volts. So if this one over here is already 1 volt, then that means that V3 would have to be 3 volts. V3 would have to be 3 volts. Because then you've got 3 volts over here, plus 1 volt over here, which gives you 4 volts, and that'll be the same as this pathway over here. Then the last question, so let's just answer this, 3 volts. This question here says, what is A3? Well, A3 is over here. So what happens is that the 5 amps enters, 2 amps went this way, 3 amps goes this way, and then it all comes together again over here and then carries on as 5 amps. Remember, in series, current stays the same. So that would be 5 amps. So what I was trying to show you here was that A2 plus A3 will be the same as whatever the current is in A1. Okay? And also just remember that A1 and A4 are the same. So we could say that the sum of parallel currents is the same or is equal to the current in the main circuit. Now, when I say main circuit, I'm talking about this part that is in yellow, okay? The part where it has not split up. So the sum of parallel currents. So what do I mean by that? When you say sum, it means plus. So when you plus the parallel currents together, so 2 plus 3, that'll be the same as the current in the main circuit. And so there is our next rule. The sum of currents in parallel is equal to the current in the main circuit. Okay, so that's what I've showed you there. So just remember these two rules, And then the next thing I want to talk about is this formula that I showed you here. So to calculate the voltage of the battery, you take all the voltages in series. Now, if we look carefully, if you look at all the part that's in series, which was all the way up to there, and then it was also this part, there are no voltages. Okay, so we just ignore that part. And then it says all of the parallel branches. But now here's where you got to be careful. Where do we see parallel? Well, the parallel part is over here. So you only choose one of them, because you can either choose V1, you could either choose the total branches, you either choose the total path of this top one, or you choose the total path of the bottom one, or you just choose this one over here. So the battery voltage, you're either going to make it equal to V1, or you could make it equal to V2, or you could make it equal to V3. Remember, they're all equal to each other anyways, but just don't add all of these numbers together. No, you only choose one of them, okay? Now let me show you something else that's quite interesting. So you could say V1 is equal to that, or you could say the battery is equal to V2, or you could say that the battery is equal to V3. And we would have normally added any voltages that are in series, but we just said that there weren't any. So let me show you some examples. All right, so we've said here that the battery voltage, which is over here, is equal to the sum of all of the voltages in series. But if you look at the circuit, there are no voltmeters in the series. You can't say this is one of them because that is the battery's voltage. So we don't have anything over here. Then you're going to plus all of the voltages or the parallel branches. So if you look at this top pathway over here, what is the voltage of that path? Well, the voltage of that pathway is just going to be 3 plus 2, which is 5 volts. So we've learned that in parallel, the voltage of each pathway is the same. Okay, so that means that V1 is also going to be 5 volts because this pathway only has one device. Okay, so once again, we've said that there were no parts in series over here. Okay, I know that these two are in series, but they're also part of the parallel branch. So we don't include those over here. Okay, now, so the parallel branch, we've got this parallel part over here, and so what we said was when you're busy calculating this formula over here, and for this parallel branch, you only choose one of the branches. So you could either choose the top branch, so then you would say 5 volts over here, or you would choose the bottom branch, which would obviously also be 5 volts, or you could choose, if they ever connected a voltmeter like this, then you could also just choose that one, but that one would also be 5 volts, okay? So this battery would only be a 5 volt battery. So the V battery would be 5 volts. In later parts of this lesson, we're going to look at ones that have series and parallel combined. I'll prove it to you over here. Here you've got series and you've got parallel combined. Okay, so let's move on to this one now. So now we've got a couple rules that we can now remember. Right, so let's see what happens here. So it says here, in parallel, the voltage of each pathway is the same. So let's first see how the circuit works. So the circuit always starts by flowing out of the positive terminal. So there it goes, flows down here, gets to this point over here. It doesn't go this way because that's a voltmeter. Now, some of the current is going to go this way. Some of it will just go this way. And then the rest will go this way. It would then combine again to go into one current. So we are told in parallel, the voltage of each pathway is the same. Okay, so look at this green pathway. How many voltmeters are there? Well, there's only this one, okay? If you look at the blue one, how many voltmeters are there? There's also just this one. And then if you look at the purple one, there's only just this one. So it says that in parallel, the voltage of each path is the same. So this means for this circuit, V1 will be the same as V2, which will be the same as V3, okay? And that'll also be the same as, if you look at this V4, it's connected from there to there. Can you see these lines? Okay, so that V4 is connected all across the parallel part. So that V4 is also going to be the same like that. Okay, you're not going to plus them together, nothing like that. Right, the next part says that the sum of the currents in parallel is equal to the current in the main circuit. So what I mean by that is, if we have, let's say for this A1 over here, let's say we have 12 amps, okay? Now, let's say 4 amps goes this way, and let's say 6 amps goes this way, then that means 2 amps would go that way, because 4 plus 6 plus 2 is 12. Okay, and that's what we're saying here. The sum of currents in parallel is equal to the current in the main circuit. So A1 is the same as A2 plus A3 plus A4. Okay, and then also remember that A1 and A5 are the same because they are in series, and in series we know that current remains constant. Okay, the next thing, the voltage of the battery, which is over here, will always be equal to the sum of all the voltages in series. So look at the yellow part. Is there any voltages that you can see there? No, there's nothing, so we're just going to scratch that out. Plus all of the parallel branches. But now for these parallel branches, you only choose one of these. You don't choose all of them, you just choose one of them. So you could say that the battery's voltage then will be the same as V1, or you could say V2, or you could say V3, or you could say V4. Okay, so in parallel, we could say the following, that the voltage of each pathway is the same, and the sum of currents in parallel is equal to the current in the main circuit. What that means, this part over here, is that if you have, for example, 5 amps, and then if 2 amps goes this way, well then 3 amps has to go the other way. Okay, now we're going to start looking at combined circuits. So we're going to keep all of our rules with us now. Okay, so here we have a combined circuit, and these are all the different rules that we need to know. Okay, so let's see how the electricity flows. So electricity starts by flowing out of here, and it goes through this device. It doesn't go this way because that's a voltmeter, and then it goes here, and it gets to this part over here. Then some of the electricity will go this way, some of it would go this way, and the rest would go this way. And then this would go like that. Okay, so let's start with this part over here. In series, current remains constant. So remember, series is the part that is in yellow. So we could say that A1 is the same as A5. So we could say that, okay? So A1 is the same as A5. And in the next lessons, we're going to be doing actual examples with numbers. Now, let's have a look here. In parallel, the voltage of each pathway is the same. Okay, so in parallel, the voltage of each pathway is the same. So we could then say that V2, well, let's say it here, V2 is the same as V3, which is the same as V4, which is the same as V5. Okay, so we've looked at this one. Then the sum of currents in parallel is equal to the current in the main circuit. So A1 will be the same as A2 plus A3 plus A4. And then lastly, we've got this rule that we have at the top here, which says that the battery's voltage is going to be the sum of all of the voltages in series. Okay, so the battery voltage is going to be all of the voltages in series. So if you look in series, we've got this voltage meter here, so we can say V1. Then it says plus. Now we look for all the parallel parts, but this parallel part, you only choose one of those voltmeters. So we could choose plus V2, or you could choose V3, or you could choose V4, or you could choose V5, but don't choose all of them. You just choose one of them. Okay?